Okay, so in graphing these, 3 less than 3. And Bailey asked, do I start at the numbers under 3, like 2, 1, 0, -1, or do I actually put the 3 in there even though it says not equals 2? And yes, keep the number where it breaks. Put in that 3 anyway. So I plotted those dots that I just calculated. Do I fill them all in? None of them in? Some of them? What do I do? Spencer? Do not fill in the 3, but fill in the others, because it hits the others. When x is 2, it is that y value. Do I leave the dot like that?
Draw a line.
Got to connect the lines. So just saying what I saw is some people just did the dots, but it's actually a line. So connect the dots. The dots are supposed to be a guide. Can you guys get those? Can you do this?
So
Picking up on the other side, sorry, yeah.
one quick question, like when to know what's the best way to know which direction your arrow should be pointing to, or can you just draw?
Well,
it to-
because this says x is less than 3. So standing at 3, where's the less than sign? That direction. So, and does it say from -5 to 3 or just less than -3, meaning all the numbers forever?
Less than -3.
All the numbers forever. Yeah, so I'm going to start and go the direction that this piece indicated. For how long? It didn't stop, so I'm going to say forever. Jasper, what numbers should I put in the other branch for x? Sorry?
2, 1, and 0.
2, 1, and 0?
3, 4, 5.
3, 4, 5, okay. So -5 times 3 is -15, -15 plus 9. -4 times, sorry, -5 times 4 is -20, plus 9. So this is going to be off the grid pretty quickly. Three -6. 4 -11. And then something down here. Do I color them all in, some of them in, none of them in? Allie?
All of them except for the first one at 3.
So all of them except the very first one, that one stays open. Why? I don't have an equal sign in the definition. So there's the graph. And Jean Gideon, you had asked, well, the question you asked is coming up in this right now. Yes?
So when it stays open, like, so they're both open for both equations, right? The
Yep.
3 and -6. But what about, like, 1 or -1, 2, like, that one's not open?
-1, 2. When x is -1, -1 is less than 3, so it says it's defined. Plug that -1 in. -2 times -1 is 2. It hits that spot. It's colored in.
Isn't the number we're plugging in like technically less than 3? Like, isn't it like 2.99? Like,
Okay, all the numbers you can imagine. -e, -7.2, all of the numbers, absolutely every single one, including -1 that you just picked. Plugging in -1 times -2, I get +2. Plugging in 0, which is also less than 3, 0 times -2 is 0, right? I get, like, if you wanted to be a pain and be like, well, I'm gonna plug in -1/3, okay, -1/3 times -2 is +2/3.
no, I understand like how to plot it. I'm just confused about like the open hole, like the closed dot or the open hole.
Okay, so right here, right at 3 is where things break. All other numbers are actually defined.
Uh-huh.
So I got the coordinate 1, negative 2, I'm going to color it in. It was allowed to be there. The one that wasn't, the ones that don't have the equal sign, why do I put that in my table anyway, is doing the math at 2.9, 2.99, 2.999999, and all those things that sneak up close to 3 are a pain to plug in. So I'm going to actually plug in 3 and say, it's going to get really close to negative 6. I don't feel like doing all that painful arithmetic with negative 2.999, or sorry, positive 2.99.
No, I understand why you put in 3. That's not what I'm asking. I'm asking like about like the dot. Like, if it's 2.99, why can't it be a close dot? It's under. Like if it's not equal, like it doesn't have to be equal because it's still under 3. So why can't it be close?
Well, it technically is. It's the other side of that open circle. You cannot close the dot at 3 because I don't have anything defined at 3.
So does it not belong to either line, or it belongs
X
to both?
equals 3 is not declared on either line, yes.
Okay.
Okay? All right. Sophia, as we approach 3 from the left.
Negative 6.
Negative 6. Naomi, as we approach 3 from the right.
Negative 6.
Negative 6. Lucia, f of 3 itself. Undefined. What kind of discontinuity do we have, Arden? Is it dump, is it infinite, is it removable, or is it continuous? It is not continuous. Sorry, that is a math teacher. Shh. Jonathan, what kind of discontinuity is it? Removable. And Jean Gideon, the question you asked like 5 minutes ago. If you could fix that removable discontinuity, what is the coordinate of the hole?
3 comma negative 6.
3 comma negative 6. How did you know that?
Because it's where the hole is plotted.
It's where the hole is plotted. It's the one spot that's not defined there, and the problem was that the x value of 3 and both things on either side went to negative 6.
Why is it removable?
Why is it removable?
You know, like what would like tell me?
Okay, if you were allowed to put your pen down on one spot and fix the problem, could you do that? So if I put my pen down right there, does the green branch connect with the blue branch? If I colored in and put in a bridge right there,
Oh, yeah?
yeah,
Okay, so because there's an open dot connecting both the lines, it's removable?
correct.
So if that was closed, it wouldn't be infinite?
If this was closed,
It would be broken?
it,
Or whatever.
if this was closed, it would be continuous. Kindergartner test of continuity, can you put your pen down and just go?
Wait, why not infinite?
Why not infinite?
Yeah.
Okay, what makes infinite infinite? Charles, what makes infinite infinite?
It's like an asymptote.
There's a vertical asymptote. So, vertical asymptotes look like this. Does one side of 3 go to infinity? Does the y value go to infinity on either side of 3?
Yeah. Don't both.
No.
The y value, so Cameron, the y value here to me, does this y value look like infinity?
Well, no, but if you go down, it goes. to-
Okay, when x is 3, the y value is negative 6. When x is 10, the y value is negative 41. So as x goes to infinity, yes, the y value goes to infinity. Is that discontinuous? No. There is an x value for all of these things. Okay. Right at 3, is this going to infinity?
No.
So is there an infinite discontinuity at 3? No. On this one, Charles just said, okay, if there's an asymptote, that's going to be an infinite discontinuity. All right, we'll work on it, Spencer.
For the limits, when it says x plus 3, if it was a closed circle, would it be different?
for this one?
Yeah. Or either, actually.
All right, we'll get there.
And also, is like the limit the X value, or it's the X value, right?
Okay. All right. So the Delta math that is assigned for homework, that is the quiz review, it asks a lot of these questions, and hopefully if we don't finish going through them today, which doesn't sound like we will, they're on there. So, not asking from either side. The limit is x goes to 3. Joaquin, where does the y value go? From either side of x equals 3, so I'm coming along this way. Where is the y value?
3.
No? Kevin?
-6.
-6. So, sorry Spencer, I lost track of what your question was now.
Well, okay, so you should explain that.
So this is the x value.
Up in the half of that.
As the x goes this way, f of x stands for what is the y value doing. So the answers to these are y values. The question is, given the x is doing this, where is the y value going?
Okay, I understand.
Okay. Can you do this question? It's on the top of page 10. How do you find the domain, guys? What is that asking?
How many, all the X
All the
values?
x values that can go in. So,
Okay.
and I will say on the quiz, things that go off the graph, assume they go forever. So, does it look like there's any x value that we were not allowed to use? Is there any x value that does not have a y value?
Wouldn't it be -4 or -5? The
So,
graph is never gonna hit -5.
well, this is an exponential. Like, does it look like it's going, okay, if I want to say it's an asymptote, I should draw that little dotted line in there to be like, it doesn't cross this, but I didn't do that, so what does that mean?
There's no X value you can't plug in.
Right, so, it's not doing this, but it is going forever up and out.
Yeah.
So all the x values are okay. So how do I say that?
All real numbers.
All real numbers, negative infinity to infinity. What's the range? Here are all the y values that can come out. 0 to square brackets, round brackets, mix and match,
Mix and match.
both round.
No, I think it's
Round.
yeah, it's square on the 0 and then the infinity is round.
Okay, is it square on the 0? So, love the explanation of to the half. Okay, so here's one sheet of paper, and then I did to the half. I did to the half again, and I did to the half again. Am I ever gonna have 0 paper? It's half. I gotta keep half. Gotta keep half. It's gonna get smaller and smaller and smaller and smaller and smaller. Do I ever have 0?
No.
So is it a square bracket or a round bracket on the 0? Round. It gets closer and closer and closer, but never down to 0. Okay, you guys write end behavior for both ends. Proper limit notation. Show me you can do that. Yes,
Would the round behavior be
The
0?
right and behavior.
How do you even find that again?
You see, like, it flattens out at 0, it's not gonna go below 0. And then the left hand behavior would be
Oh, it's the limb.
Oh, that's what it says, right?
What are you guys doing?
I still can't think of what he said. Commander season last year, bro.
Yeah, is there right and behavior?
So this guy Nate over here said that the Commander season last season was a fluke.
actually.
I said that's the big, and then I said that's the biggest rage rate of the year.
Deadass.
Yeah, you know what I think every once in a while? If like Brett's like super tall, huge, six pack, he just like
I don't think I ever saw him massive.
Oh my god.
I know.
that's so-
I mean, you could tell. Like,
what if that's a Gerber, bro?
yo, he shaped it.
From all, like, A1,
Bro, I swear that was so sick.
all three of the
Like,
shirts. It was
yeah.
white. It was a white shirt with gold and red on it.
I thought this that so
They're not coordinates, and that's not notation.
I'm like shaking, I'm just ready.
I think I kind of forgot the bit right and left.
Okay, again, please do the homework. If you don't do the homework and don't know what you're doing, this is in the homework. This is also on the test. Yeah.
We're not gonna do bound.
Okay, so I skipped those two on here. Boundedness is a property that, it's very simple. It's bounded below when there's a floor. Bounded above when there's a ceiling. Is there a floor or a ceiling to this graph? Is there a lowest of the low that this graph does not ever cross?
0, right?
So would you say this has got a bounded below issue or bounded above?
Below.
Below, it's got a floor. So this is bounded below, it's got a bottom. One that is bounded above, it's like a downward facing quadratic. It's got a ceiling that it's not gonna get over. Algebra 2 last year, were there any functions that stayed squished like an ice cream sandwich? You know what I mean?
Oh, yeah.
What was sine and cosine?
So wouldn't it be bounded below and above?
That's bounded above and below. And G, are there any functions that are unbounded, they're just crazy? Like y equals x. So, I don't care about that for this quiz on Monday.
What about an equation of asymptote on the quiz?
Just, hold on. Let's write the end behavior. So Cameron, how do we write the end behavior for the right side? Using limits. LIM.
To the right side, so that's from the negative, so, wait,
Okay,
confused with this one.
okay, right end behavior. Tim, at the end of time, what's the x value when we reach the very, very end of time? Infinity. So as x goes to infinity, where is the function's y value super that way? Where is it?
0.
It's getting really, really close to 0. I'm never gonna have 0 paper, but it's getting close. Tim?
Whenever we write these and we're not given the name of the function, do we default to f of x?
Well, there. Y equals f of x. I will try to make sure they're named. Okay?
And if there aren't, what should we write?
Pick something reasonable, but don't leave it blank. Tessa?
So we have to know the equation of the asymptote.
Not yet, but we'll talk about it if Belle doesn't read. Leah, what's the left end behavior? In limit notation, LIM, x arrow, what? What's the x value when we get that way? Beginning of, what? The x value at the beginning of time. What's x way up? Negative infinity. Noah?
Yeah.
What is the end behavior at the beginning of time for this function?
Positive infinity.
Positive infinity. Okay. And horizontal asymptotes, so there was a question on there saying, tell me the equation of the asymptotes. It's not on Monday's quiz, but vertical asymptotes, I don't have any of those. Arden?
We left and goes at the bottom where there's like the negative infinity. Does it matter if you put the negative in front of it or behind it?
It matters.
Because it like sometimes changes, you know?
It doesn't change.
Well, like sometimes, like it'll just be like X and then an arrow and then it's infinity would get the negative like on top.
I've never seen that.
Oh, I know it goes back. It like changes.
Oh, yeah, it
You can't really sneak up on infinity from the left.
Well, I don't know, it was delta math.
Okay,
It like said it.
if you could snapshot that for me, I have no idea what you're talking about.
Okay, but then how do you like, so when you write it
So,
on top, like how do you know to do that?
It's one of these two things. You're either going to positive infinity, and there is nothing, like, from a number, you can sneak up on a number from the left or the right. You can't sneak up on infinity. Like, there's never gonna be a thing in those spots.
Okay, so
and-
if it's like a real number, like let's say for example it's like 5, how do you know to like, put the negative in front of it or behind it?
Okay? This thing written as an exponent is 3 from the side where negatives are. This one is 3 from the side that has positive. And then there is just, the limit as x goes to 3, just by itself, no stated direction. That's from either direction, are you going to a predictable place? There is no little exponent thing for the infinities. And if you see that on in Delta Math, send it to me. Thanks. So, asymptotes, horizontal asymptote from pre-cal algebra 2 last year. Does this have a horizontal asymptote? That means as y is going to one of these ends, is it settling down somewhere? Tim, what would you say?
That y equals 0.
Yeah, so y equals 0 is a horizontal asymptote. At the end of time, it's doing some nice, stable, simple thing. It's hanging out at 0. Okay? All right. Here's the one that's hard. There's 3 pieces. Can you graph it? -3. Constant the whole time from -1.
Whoa.
Open circle.
Where are you at? What's -2 minus 5?
Wait, Buzz, you say you want to be in forensics.
What you say you wanted to be? At UND? I know, but what do you want to do when you...
There's so many different things.
You want to be like the cops on horses? Or the ones from on the bikes from 22 Jump Street?
Oh, yeah. Yeah, that's a good movie, bro.
I know, that's my favorite movie, bro.
Yeah, actually,
I love Rival.
that
You're joking.
ride along. I've not.
With Kevin Hart.
Oh, I think I've heard of it. I'm not
Is that with the Rock?
Yeah, The Rock and Kevin Hart are always in the same.
Rival, Kevin Hart. And
Ice Cube.
yeah.
Ice-T?
Okay, so guys, I am seeing either correct graphs or no graphs, as we were talking.
Oh,
Is there gonna be one with 3 on the quiz?
can be.
It's our first time.
What?
Um,
Yeah, we've never done this until now.
okay, could you whine a little more? Perhaps not talking would be helpful, just an idea. Okay, this one, it's a constant, it's a flat line. There is no x value to plug in for. And Lucia drew this. She said at -1, she made a closed circle, and then she made these other dots, and at 4, she made an closed circle, and then just connected the line. And she said there's no arrows, right, because it's cut off from x equals -1 to x equals +4, draw this, and stop. Yes, that's correct. Okay. Doing this one, less than -1. Putting in -1, -2 times -1 is +2, -5, that's a -3, open circle. Okay? Now, I'm gonna graph using geometry, not the table. I have a coordinate. What's the slope on this line? 2 or -2, which one? -2. So from here, I need to do slopes this way. Go up to back 1, up to back 1. Okay, the other one, someone who got the guys, this one is an asymptote.
I know. On the phone.
Please do the delta math homework.